All right, let's talk about solution concentrations. And in this section, we're going to look at things like molarity, which is the number of moles per liter. We're also going to look at percent mass over mass and percent mass over volume. And we'll even look at percent volume over volume. So let's start with molarity and let's define concentration. Concentration is the relationship between the amount of solute and the specific amount of solution in which it's contained. So we have solute, our solute, and what we're going to do is we're going to divide that by the amount of the entire solution. And the first type of concentration that we're going to look at is molarity. And it's when a solution is concentration is expressed as the number of moles of solute contained in 1 liter of solution. So put another way, you could just say it's the number of moles of solute per liters of solution, okay? So molarity, big M, is the number of moles per liter. So I got my calculator here with me. Let's see if we can solve a couple of problems here. The first one says, express the concentration of each of the following solutions in terms of molarity. And remember, molarity is big M, which is equal to the number of moles per liter. In A, it says we've got 2 liters of solution that contains 1.5 moles of solute. So our molarity, big M, is going to be the number of moles per liter. We have 1.50 moles. We have 2.00 liters, like that. Don't need a calculator for this one. 0.750 moles per liter, or we can just say 0.750 big M for molarity, moles per liter. Okay, so in B, they're saying a 315 milliliter solution contains 10.3 grams of isopropyl alcohol. Express the concentration in molarity. So remember, molarity, which is big M, is equal to the number of moles per liter. Well, they didn't give us the number of moles of isopropyl alcohol. They gave us the number of grams of isopropyl alcohol. They also didn't give us the volume of the solution in liters. They gave it to us in milliliters, but we can work this out. So let's start with the 10.3 grams of isopropyl alcohol, C3H7OH, like that. And we know that in 1 mole of C3H7OH, we have how many grams? So let's just tally it up quickly. So if we have 3 carbons, remember carbon has a molar mass of 12.01 grams per mole. So we take 12.01 grams per mole. We multiply that by 3. Hydrogen has a mass of 1.01 grams per mole. We multiply that by 8. Right? We have 7 plus 1 gives us 8. And then we have the mass of the oxygen, which is 16.0 grams per mole, and there's only one of those. So we're going to take our 12.01 times 3, that gives us 36.03 plus 8.08 plus 16, and that gives us 60.11. I'll just leave it as 60.1 grams per mole, like that. So we'll put down here 60.1 grams of isopropyl alcohol, C3H7OH, in my 1 mole. And so you can see here using my dimensional analysis that grams of isopropyl alcohol cancel and we're left over with moles. So we get 10.3 divided by 60.1. That gives us 0.171, so 0.171 moles. Then to convert the number of milliliters into liters, well, hopefully you remember there's 1,000 milliliters in 1 liter. So we're going to say 315 milliliters. And we know in 1 liter we have 1,000 milliliters. And so mils cancel out. And so we're left over with 0.315 liters. And now we can take both those numbers and we can solve our problem. So we can say molarity is equal to 0.171 moles divided by 0. Sorry, my iPad had a bit of a hiccup there. So molarity is equal to 0.17 moles divided by 0.315 liters. So we take 0.171 divided by 0.315, and we end up with 0.542 moles per liter or 0.542 molar, like that. That's the way we pronounce that. We would say molar is the concentration. All right, let's move on to percent concentrations. And I told you we would discuss weight over weight percent. And so a concentration that is expressed is the mass of a solute contained in 100 mass units of the solution. The mass units of the solute in solution must be identical. So a lot of times we use the solute mass in grams divided by the solution mass in grams and then multiply it by 100. And then if we want to do weight by volume percent, that's a concentration that expresses the grams of solute contained in 100 milliliters of solution. And so a lot of times we just use grams and in milliliters. Okay, so grams and milliliters for weight over volume percent. I recommend memorizing these. These formulas are very good to memorize. So percent weight over weight, percent weight over volume. I would also recommend memorizing volume over volume percent, and you can probably guess that it's a concentration that expresses the volume of solute contained in 100 volume units of solution. And so it says here any units can be used, but they must be the same. So let's say you use milliliters here, you'd want to use milliliters in the denominator as well. Again, I recommend memorizing percent volume over volume. All right, let's try a problem. It says the majority of drug concentrations are expressed as a unit of mass per volume percent. A 500 milliliter IV bag of 0.90% saline solution. Saline is just, if you've ever wondered what it is, it's just sodium chloride in water. So 0.9% saline is hung for a medical patient in their IV bag. Calculate the mass of sodium chloride in grams required to produce the solution. Well, remember our formula that percent weight over volume because we're talking about grams per milliliter. So percent weight over volume. We said we were going to have the solute mass in grams divided by the solution volume in milliliters, and then we're going to multiply that out by 100%. So they're telling us that we have a 0.90% saline solution. We're looking for the number of grams of sodium chloride. I'll just call it X. I mean, I could just put sodium chloride mass in grams here, divided by the entire volume, which is 500 milliliters times 100%. And so all we have to do is solve for the mass of the sodium chloride. And so when we rearrange that formula, we're going to get the mass, or I'll just put NaCl in grams. So we'll put here NaCl mass in grams is going to be equal to, so it's going to be 0.90 divided by 100 multiplied by 500. Like that, just doing a little quick algebra here. So we take 0.9 divided by 100, 0.009 times 500, and that gives us 4.5. So the mass of our sodium is going to be sodium chloride rather, is going to be 4.5 grams. So we have 4.5 grams of NaCl in the 500 milliliters of our solution. Okay, question B. A solution is made by mixing 90 mils of alcohol with enough water to give 250 mils of solution. What's the percent volume over volume? Concentration of alcohol in the solution. So our percent volume over volume is going to be equal to the volume of solute in milliliters divided by the volume of solution in milliliters. And we're going to multiply all that by 100%. And so we end up with percent volume over volume is going to be equal to 90.0 mils divided by 250 mils multiplied by 100%. And so 90 divided by 250 multiplied by 100% gives us 36.0% volume over volume. There we go. All right, let's take a look at solution preparation. And in order to prepare a solution, you have to know how to do a dilution. And you can see here is a pharmacist who's making some kind of dilution from a stock solution. And if you've ever made orange juice from concentrate, right, you'd be doing a dilution there. So solutions can be made by diluting a concentrated solution with a solvent, usually water, to produce a solution of lower concentration. And so if we think about what molarity is, right, molarity, big M, right? Big M is equal to moles per liter, right? So if we take molarity times volume, what does that give us, right? It's moles per liter times liter. The liters cancel out and we end up with number of moles. And so when you do a dilution, right, if you multiply the initial molarity and the initial volume, right, you just get a number of moles, and you don't change the number of particles when you do a dilution. So the number of moles at the beginning is going to be equal to the number of moles at the end, right? So that's why we can write out this formula. The initial concentration times the initial volume, M1 times V1, is equal to the final concentration by the final volume, M2 V2, like that. So this is a formula you definitely want to know. M1 V1 is equal to M2 V2. I call this the dilution formula. Okay, so let's say you wanted to prepare a solution of 250 milliliters of a zero point 0.1 molar sodium chloride solution using a 2 molar sodium chloride solution as the source. Okay, so what they're telling you is that this is the final volume you want. So this would be your volume or your V2. This is the final concentration. The final concentration. I don't need the word of in there. So this would be your final concentration, which would be your M2. And this is the stock solution, right? The concentrated solution you're starting with. This would be the M1. So if we look at our formula, M1 times V1 is equal to M2 times V2. What you're looking for is you have V2, you have M2, you have M1. So you're trying to solve for V1. And so you can rearrange the formula. Permit me to just write it over here on the left-hand side of the screen. So V1 is going to be equal to M2 times V2 divided by M1, like this. And so if we take our M2, which is going to be our 0.100 molar, 0.100 molar, and we multiply that by our V2, 250 milliliters, and we divide that by our M1, which is going to be our 2.00 molar, like this. You can see that the molarity cancels out. So now if I take um, zero point 0.1 times 250, which you don't really need to do on a calculator, that's 25, and I divide it by 2, I end up with 12 and a half. So my V1 is going to be equal to 12.5 milliliters. So what it's telling you then is that you would have to take 12 and a half milliliters of that initial solution, the stock solution, and you'd have to dilute it up to 250 milliliters. And that's what you see is happening here. Somebody is taking, you know, a bit of this concentrated solution, putting it in this volumetric pipette, and then they're doing the dilution in this volumetric flask. Okay, let's take a look at example 6.11. It says use the equation 6.12, so M1 times V1 is equal to M2 times V2 to describe how to prepare a 250 mil, 5.00 weight over volume, 5.0% weight over volume dextrose solution using a 25% weight over volume dextrose solution as the source of the dextrose. So this is going to be our V2. This is what we want. This is going to be our M2. And this is what we're starting out with. This is our M1 right here. So we're solving for V1. So we're going to write down our formula. V1 will be equal to M2 times V2 divided by M1, like this. So we have our 5.0% multiplied by our 250 milliliters. And then we divide that by our M1, which is going to be 25%. So we see that these cancel out. So we take, and again, probably don't need a calculator for this, but 5 times 250. So we get 1250 divided by 25, and that gives us 50. And so we'll put that down here. We'll put 50, 50 milliliters. And so how would you describe it? you would take 50 mils of the stock solution of the 50 mils of the 25% weight over volume solution, then dilute to 250 milliliters, and then you'd end up with your 5.0% weight over volume dextrose solution.